Hello friends, welcome back. In this session, let's try to find out the derivative of log x. So using the first principle of derivative. So we know the definition of f dash x is limit of f of x plus h minus of f of x by h as h tends to 0. Let us find out what is f of x plus h here. That's nothing but equal to logarithm of x plus h. And also we know f of x equal to logarithm of x. So let's substitute in the formula. We'll have f dash x equal to logarithm of x plus h minus logarithm of x divided by h. Limit of this h tends to 0. That's equal to, I'll write down again, limit of this as h tends to 0. This is in the form of log of a minus log of b. So I can write it as log of a by b, one of the rules of logarithms. So I can write it as x plus h by x divided by h. Which formula we have written? Log of a minus log of b equal to log of a by b. So we have now that's equal to limit of h tends to 0 logarithm of 1 plus h by x divided by h. Now we know that a limit as h by x tends to 0 log of 1 plus h by x whole to the power of x by h is equal to 1. So let me write it down. We know. Now we want to make it to a reasonable number, value 1. So what we will write? We know that log of 1 plus h by x whole to the power of x by h equal to 1 as h by x tends to 0. So there should be a limit here. We know that limit of this whole thing as h by x tends to 0. We know that if h tends to 0, automatically h by x also will tend to 0, because 0 by anything will be 0 only. So we know this. So let's try to leverage that and say, therefore this is nothing but equal to 1 by h into limit of h by x tends to 0. I will have logarithm of 1 plus h by x to the power of x by h, so that I can make this as 1, but I should immediately balance it out so that I will go back to 1 there. So this, what we have written is log of 1 plus h by x. I need x by h so that I can write this whole thing as 1. So I have to write there to the power of x by h, but I should balance it out, so I have to multiply immediately by h by x. Now this is in the form of log of a whole to the power of b, which you can write it as b into log of a. So I can go ahead and write it as 1 by h into h by x. This h by x I can bring it to here. Then I will have log of 1 plus h by x to the power of x by h as limit of this as h by x tends to 0. Let me just write it in another color so that there is no confusion there. X by h, this is equal to 1 by h into h by x into limit of that as h by x tends to 0. But this is equal to h cancels, 1 by x into 1, that's equal to 1 by x. That's equal to 1 by x. So if f of x equal to log of x, f dash x is equal to 1 by x. So whenever you see logarithm of something, then you know immediately log of x. That means the derivative is 1 by x. Let me repeat that, how we have done that, just summarizing. The derivative formula is f dash x equal to limit h tends to 0, f of x plus h minus f of x by h. We know f of x plus h is log of x plus h, f of x is log x. So f dash x is log of x plus h by x by h. I can take 1 by h out. I have logarithm of 1 plus h by x. But we know that logarithm of 1 plus h by x whole to the power of x by h equal to 1. So we have placed x by h, and again we balanced it by putting down again h by x. Now we know that this is of the form log a to the power of b. I can write it as b log a. This whole log a will become 1, and we left with 1 by x into 1. That's nothing but equal to 1 by x. So the derivative of log x is equal to 1 by x. If you are able to understand these 3 or 4 formulas related to logarithms and a power x and e power x, it should be very easy to understand this. So thanks for your time. I'll catch you again. In the next session, we'll see the properties of derivatives. That means derivative of two functions is nothing but equal to sum of the derivatives of the sum of the derivative of two functions is equal to sum of individual derivatives. So we will see sum, product, and also division in the coming sessions. Thanks for your time. Bye for now.